Hello again, chemistry students. Today we are writing formulas for binary ionic compounds. So in the last video, we looked at how do we name a compound when we're given the actual formula? How do we name it? Here we are given the name and we need to write the formula. So we're going in the opposite direction. So in order to write formulas, you're going to need your chem helper because you're going to need to know what the abbreviations for all of these elements are, but also you are going to have to know what the charge of the elements are as well. And those charges can be found at the top of their family. So at the top of the family, for instance, if you look, if you need to pause this in order to get your chem helper, then do it so that you know exactly what I'm talking about. But at the top, for instance, of the hydrogen column, like where you have the box on your chem helper for hydrogen, you're going to have a +1 above it. That means that all of the elements that are in that family, all of the elements that are in the same column as hydrogen, form a cation charge of +1. If you look over on the non-metal side, let's just say take a look at the square that has oxygen in it. Oxygen has a -2 at the top. And so all of the elements that are in the same column or in the same family as oxygen are going to form an ion that has a -2 charge. That means that they gain 2 electrons in order to achieve their full valence shell. Now, the only one that's going to be a little bit weird is carbon. So if you look at the top of your chem helper, go ahead and find carbon. That's atomic number 6. So you have carbon, and then below it you have silicon, and then below silicon you have germanium. And above carbon, you have 2 charges. You have -4 and you have +4. Well, what that means is that carbon and silicon are going to form charges of -4. And then, like below silicon, you have a part of that staircase. Germanium and the rest, you have SN for tin and PB for lead and FL for fluorovium. All of those are going to lose electrons. They're going to form a charge of +4. So I just wanted to make sure that you knew what all of that meant. Okay, so before we start writing formulas, there's something that you need to remember. And that is whoops, I lost my text box there. Okay, so the thing to remember is that ionic compounds have a neutral charge. And what this means is that the charge of the cation must be equal and opposite the charge of the anion. And so by equal and opposite, what I mean is that if the charge on the cation is +3, that means that in order for the formula to be correct, the charge of the anion must be -3. So they are equal because they're both 3, and they're opposite because the cation is positive and the anion is negative. And so that's what equal and opposite actually means. Okay, so let's put this all into practice. And if I were you, I would pause this video right now so that you could write what I put in red at the top of your page, so that you remember like why we are actually doing this. Okay, so let's take a look at number 1 on this page. This is sodium selenide. And sodium, if you look on your periodic table, is atomic number 11, and its abbreviation is Na. If you look at the top of its column, it has a charge of +1, so I'm going to put a plus there. Now let's look for selenide. Selenide is atomic number 34. Its abbreviation is Se. And if you look at the top of its column, its charge is -2. So if you look at the charges, that you can see that they are not equal and opposite, because sodium has a charge of +1 and selenide has a charge of -2. So in order to make them equal and opposite, we need to add a second sodium, like so. Now, when you add the charges on sodium, a +1 and a +1 equals +2. And selenide, as you can already see, just one selenide is -2. So by having two sodiums and one selenide, we now achieve equal and opposite charges. And so my formula for sodium selenide would be Na, and we have two of them, and we show that we have two cations by writing a subscript of 2. So when you guys write these, you have to be sure to be deliberate. Like, I don't want to see like Na2 like that I'm gonna mark that wrong. You have to be deliberate and you have to write neatly, and you need to make that 2 as a tiny subscript. And then we have only one selenium. So we write Se, like that. And remember, we don't typically write the ones in chemistry. I just put the 1 here by this sodium so that you could see how I got the +2. But this would be the correct formula for the compound sodium selenide. So there's another way that you can do this. Let me show it to you. This is a way that is called the crisscross method. Crisscross applesauce. So here we go. Sodium is Na +1. And selenide is Se -2. And if you don't remember how I found the +1 or the -2, all you got to do is find the elements and look at the top of their family, because the charges are there on your chem helper. So that's why you've always got to have your chem helper with you. Okay. So here's how it works. Here's how crisscross applesauce works. So in order to figure out what the subscripts are, you're going to take the 1 from the sodium and bring it down to selenium. And you are going to take the 2 from selenium and rewrite it here at the bottom of sodium. So what you get in the end is Na with a subscript of 2. So notice that I'm color coding this for you. And you have Se with a subscript of 1. But like I said, we don't write ones in chemistry, so I'm going to erase that pink 1, and this here is your final answer. This is sodium selenide. Okay, let's try another one. And I'm just going to keep on using pink and green, pink for my cations and green for my anions. So hydrogen is H. It has a charge of +1. And chloride, that is the anion for chlorine, that is atomic number 17, and its abbreviation is Cl. Now be careful, because that's not Ci, that's C, big capital C, lowercase l, and chloride has a charge of -1. So to figure out the formula, I'm just bringing down the 1 from hydrogen and writing it over here by chlorine. I'm bringing the 1 from chlorine and writing it down here by hydrogen. Notice that I'm not carrying over any of the charges. So I have H1, and then I have Cl1. But remember, we don't write the ones as subscripts, so I'm going to erase them. And this is finally our final answer. That is the formula for hydrogen chloride. So hopefully as you guys do more of these, you're going to be able to get faster, and maybe you won't have to like write the arrows like for crisscrossing and stuff like that. All right, beryllium nitride. So beryllium is atomic number 4, and its formula is Be, and if you look at the top of its family, it has a charge of +2. Whereas nitride is the anion for nitrogen. Its atomic number is 7, and if you look at the top of its family, it has a charge of -3. And so my 2 is going to be rewritten here by the nitrogen, and 3 will be rewritten all the way over here by beryllium. And so I'm going to write Be3N2. And this is my final answer. So notice that I didn't have to erase anything because I don't have any ones as subscripts. So the answer for beryllium nitride is simply Be3N2. Okay, so just getting better at this, aluminum is atomic number 13, and it has a charge of +3. So now I'm going to put in a little bit less information since now you should be getting the hang of this. Aluminum is +3. Sulfide is the anion for sulfur, and sulfur is atomic number 16, and the charge at the top of its family is -2. So I know that I need to write the 2 for sulfide next to aluminum. And I know that I need to write the 3 by aluminum next to sulfide. And so this here is my final answer. All right, so now I would like you to please do the rest of this page and check your answers against the key. And if you're having trouble, I wrote a tutorial for you that I put into your packet. It's called writing formulas for binary ionic compounds, and that's written in my voice. Like I wrote that for you. So it'll show you step by step how to go ahead and write these formulas. Good luck, you guys. I know that you've got this.